Hi and welcome to the Project Data Analytics Part 5. In this part we will see the introduction to the DAX, we will see some important functions and operators of DAX, and then we will write some DAX codes to create the key performance indicators. So let's move into Power BI. So we are in Power BI. Previously what we have done, we have developed the data modeling. In the part 2 and 3 we have done the data structuring, then we brought all the data from P6, we did data structuring and Power Query, then we did data modeling, we connected all of these. Now we know how they are connected to each other. Now we need to develop the key performance indicators. Why we are going to do that? Because we know that the data has so much information already, like the earned value is present there, planned value present there, budgeted units, baseline units, dates, everything is present. But we need to organize the data so that the key performance indicators can be generated, and then whatever we need in our visuals and reports we can have them, and then we can use the filters so that the data can flow from this network. So before doing that we need to know how to do that, because so far we didn't do anything inside Power BI. We did only the data structuring inside Power Query. So if you want to write, or if you want to adjust the data, or if you want to maneuver something inside the data, how we can do that? We can do that through the DAX. So what is DAX? DAX is data analysis expression. It is a language just like VBA and the Excel language for the formula. For example, you write if command in Excel to write the formula so that the Excel does operation for you. So similar things will be done here. So there are 2-3 ways to write the data or to write the DAX code. So one of them is simply the measure, which we call measures. Measure is a operation which we do in the DAX language. Let's say I can tell the DAX to calculate the sum for me. So it can be done in two ways, a measure way and the calculated column way. So the difference between measures and calculated column is that, you see, this is measure, this is column. This is also one of the way to write. This is a new measure, quick measure, like predefined formulas in DAX language, so you can quickly use them. But the theme is that these are the two different categories of writing the data or adding something in the Power BI. What is the difference between measure and the calculated column? Measure is a scalar value. It's a simple one aggregated value. It can be the sum, it can be minimum, maximum, average, and latest, earliest, all these values. While the new column is an iterative operation, like iterative value, it can repeat multiple times in the form of rows. So if I talk about this value right now, this date, if I say it is a measure, it will be a wrong term. It is a calculated column. Why? Because the value is repeating against each row value is repeating. So that's why it's also called the iterative. So the difference is that whenever you have measures, you cannot see measures in any where in the sheet other than the visual. For example, if I want to write a measure here, we will go into the syntax, that how to write the measures, what syntax you need to use, what are the context of filter using the measures and the calculated columns. So point is there, what we have, that measures, you cannot see what is inside the measure unless you brought that measure into the visual. But calculated column, once you write the calculated column without bringing it into the visual, these are the visuals, you can know the value. How? For example, let's assume that was the measure I calculated. I can see it right now here, but that was calculated column, new column. But measures we cannot see here, because for measures we need to bring them into the visuals. This is and also we know that the measures are only the scalar values, not the iterative values. These are the things. Now we will see how we can write the measures and how we can write the calculated columns. So some of the basic operations we will start with. So now I will go into the, let's say here in earned value cost distribution, we know the terminology. I want to calculate the percentage of this, or let's say I want to calculate the cumulative of this. So we will go into the detail of cumulative, how we can write. So first I will calculate the percentage. How I can calculate? There is a quick way. First I will go to show you how the quick way works there, and we know that percentage always comes with a divide. So first I will go into this, click right, and it will open up a new window for me. So now I know I need a division operation. These are the predefined some operations here and the functions which you can use, but we will mostly be using the measures and calculated columns by ourselves, because we need to write some complex formulas. So the percentage, our task is to calculate the earned value percentage, which is also referred to as performance percent in P6. So how we can do that? By dividing this with what? The baseline value or the budgeted total cost, means the project budget. And we know that project budget, where it is available. Now guys, this is a time we need to understand the data and we need to memorize data in our mind as a visual, that how data is stored. If I talk about the how data is stored in activity window inside P6, we know that okay, the data is not in distributed way, data is in this way. So we know that okay, it's a roll up, roll down, it's a drill up, drill down value. But if I talk about resource assignment, let's say, now we know that data is present in two forms, roll up, roll down, and horizontally distributed as well. So this visualization should be in your mind when you are writing the DAX code, so that it will give you little idea. Similarly, if I want to see the earned value, so for earned value I need to click here, activity user spreadsheet. Now I know that earned value is present for me in roll up, roll down, and the distributed as well. So let's say if I want to see earned value is there, and this DIS is telling you that it's a distributed value over the time period. We need to divide it with the budget cost. So where we can find the budget cost? Definitely if we see in P6, the budget cost comes here in this part. For example, if I bring here the budgeted total cost or budget at completion, which is the same thing, budget at completion here. So we need to know that. Why I'm telling you this? Because now I want to go into this table, this activities table, where this table is lying in our data model. It is here, activities fact table. So now you need to understand that activities fact table means the activity table of P6. Activities distributed table means this is a distributed data. It is carrying the distributed data of 6 different types: actual cost, actual labor unit, earned value cost, earned value labor unit, planned value cost, and planned value labor unit. So these are the 6 different types which we separated here. Earned value cost as a separate. So these 6 values are coming from this part. So you just need to memorize that, so that it will help you for writing the DAX codes. So if we talk about the roll up, roll down value and the fact table, so we know that fact table do not have the distributed value data. It is only having the roll up, roll down level data, like WBS level data or control points, whatever you have. So now my point is to divide it with the project budget. So project budget will be present here. Sorry. So now I need to go in here in this part, and what is this? This is C is telling me cost. If it was L, so I would have taken budgeted labor unit, but in my case it is budgeted total cost. So I will just take the budgeted total cost, and now this is a simple way of writing the DAX. So now DAX is coming. So it by default it will give you the formula like earned value cost distribution is divided by budgeted total cost. So we can just rename that as per our requirement, earned value distribution cost, and we know that it's a percentage. Okay, how we can convert that into percent? Right now it is not in percent. Just click on that and go here, click percent. Once you click percent, you need to just change to 2 decimal, 3 decimal, whatever you feel better. Okay, so this is done. I will do that again quickly for the earned value labor unit. Let's say this. Now I will go into quick measure. I will go here, divide this value with what? Activities fact table and budgeted labor unit, not the cost this time, because this is a labor. So sum of this, both we can use a count maximum as well, but we don't want, we want sum of this. So this is done. So this will give me the earned value labor unit. And what is this in P6? It is called the performance percent complete labor unit. If I go into perform here, this is the one, performance percent complete labor, performance percent complete simple cost. So that's what we have done, and we can name it easily here percent. So that was the quick way of writing the DAX. So if you want to write by yourself the formula, how you can do that? So let's say I will go into planned value. I want to make a percent for that as well simply. So what I will do simply, I will go here, new measure. Now the window will open for me and the formula bar is there. So now I need to write the formula. So now I will tell you a little bit of syntax how to write the formula. What we are going to do, we are going to planned value cost distribution percent. We want to calculate. What we need, simply we need to use the operator divide. So divide is telling me that numerator should be the sum of, why? Because you see this summation sign is telling me that this is not a measure, this is a calculated column. Why? Anything which is measure should be having this symbol, a calculator symbol with that. So right now it is not a measure. So if anything is not a measure, it is a iterative, or means function iterative value which is repeating in multiple rows. So we need to find a scalar value for that. So how we can find a scalar value? So I will just go and back and show you what I am saying actually. Let's say I am in the data tab here and I am inside this plant value. Inside plant value there are values. See, plant value distribution, these values are repeating so many times. See, there will be so many times it is repeating. But if I want to convert this iteration in a scalar value, I need to have an aggregation. It can be an average of this complete column, it can be maximum value, it can be minimum value, or a sum value. Anything should be which is giving me a single value, scalar value. So to remember this, whenever we are using an iterative value in a DAX formula, we need to use the aggregate, yani scalar value. In order to make it a scalar, what I am going to do, I am going to say that divide the sum of what? Plant value, this is the value, plant value cost distribution. Now you see what is the purpose of writing this DIS when we were doing Power Query, inside the Power Query. See, there are so many PV which value to pick. It is telling me instantly this is the value I need to pick, okay, because this large bracket is telling me that it's a column, and this before large bracket is telling me that it's a table. So there are many tables: ACDIS, actual distribution, actual cost distribution, actual labor distribution. Inside this table there are many columns, so column is represented inside this large bracket. So I know that I want to go into this table, and under that table there are 4 columns. Right now I want to go into this column, DIS. So simply just click here, the sum of this column, and whenever you write the sum, average, minimum, maximum, so you need to close the bracket always. Otherwise, if you do not close and if you move forward, it will give you error and you might not be able to find in the initial stages of your DAX learning. So you need to be very careful with the syntax, that you close it whenever you write the sum, average, minimum, maximum, all these things. Okay, so now what we have done the numerator part, that sum of plant value we need in the numerator. What we need in denominator? We need the sum of, okay, what? We need the sum of, we now need to navigate that where our data is lying. We know that data is in activities fact table. So you can simply write that the budget, if you write budget, it will show you what are the possible options available. The available options are all inside this table. And what we need, we are using this plant value cost, so we need to take the cost here and we need to close this. And alternate option you can just remove, that means it's not necessary. So simply it is giving me the complete syntax of the measure. So this is the way you can write measure. So now it is showing a plant value cost distribution. So I can make it a percentage and I can make it to decimal places. Yeah, it is done. There is one more way to write this, which is also very simple. So what you can do, simply new measure, and I want to write is plant value labor distribution %. And what I will do, I will not go into the divide formula, I will simply go sum of, okay, what? Sum of plant value labor. Now it is giving me that this table and all available columns, okay, this one I need close that, and I want simply division of what? Sum of, and then what I need, it's a labor, so I will write BUD, budgeted labor unit, simply. So it will also give me the same result because I have used the operator as a divide here. So numerator divided by denominator, so it is also going to give me the result. So I will call this, I will make this as a percentage as well. So these are the few ways you can write the DAX code, and there are many other you can say functions, operators you can use, the average, the count. For example, let's say I want to count the number of activities. So what I can do, simply, let's say here I want to count, right click and new measure. I will say this language is similar to Excel in many ways, like these operators are quite similar. So count activity, I will say just, so simply just go count and you need to give the column name. Now what column name you want? Let's say I want activity ID. There are so many activities available. So what I want activity ID, this table. If I click here now, so it will give me the count of that, so how many counts are there. So similarly, the average, the minimum, the maximum, all the values can be found there. The syntax is same. So now we will move towards the little complex formulas, that how we can use a complex formula. So now we will go for a little bit of time intelligence formulas. So there are many time intelligence formula which we need to use. So for example, for time intelligence, what we can use, what we want to use, we want to create the project elapsed duration, project total duration, project remaining duration, and their percentages. So which we will be using in our this area. And guys, this you need to select, and you need to make one understanding where you want to put your KPIs, because there are so many tables, there are so many columns, so you should know where you have put your KPIs. For example, cost related KPIs you can put here. Cost related KPIs means measures, and the calculated columns you can put into earned value, cost, and actual cost, and planned cost. So you should decide where you have put. I usually what practice that I put all the KPIs into earned value, so that all my SPI, all my CPI related to cost, EAC, VAC, estimate to complete will be here. So I every time know that they are here. So we need to decide. Related to time functions, I always put them under this part, dates, time. So what I'm going to do here, I'm going to calculate the project duration, total duration, then we will go and calculate the project time elapsed, project remaining duration. For that, there are few measures, there are few formulas which we can use. The most common formula which we will be using under time intelligence, because there are multiple formulas. This software is not only for the project, this software is for many industries, so there are many formulas which are not related to us, but we will not be using them. So the only you can say the workable formula which I have found so far are the date difference, and you can say the start week number, week numbers, and all these we might be using. So let's start with this. So what I'm going to do, going to write a new measure, okay, and I'm going to call it the project duration. And what I'm going to do, that there are few formulas, but for us we are going to use date diff. What it does, returns a number of units, any intervals between the two input dates. So we know that the project duration is the project last date minus the project start date, so we will be using that. So there are three arguments. First argument date 1, date 2, and then interval. So what is our date 1? So it should be our minimum of, because we need to remember the shape of the data. Where we can find the baseline dates, we know that the baseline dates are always present in activities window, not in resource assignment or anywhere. In activities window, baseline dates are available, and we know that the data is in iterative form. So we need to use some of the aggregation to call. So if I just go back and show you how the data is in iterative form for the baseline dates, let's say we know that now baseline dates are present in fact table, and these are the dates: actual start, actual finish, baseline start, baseline finish, and start, any forecast start and finish, all are available. So if I go and check the baseline dates, let's say, so these dates are now iterative. We know that iterative. So in order to make the aggregation, because we need to use the aggregation in a measure, so for that we need to make a minimum or maximum. So how we can decide, so that the minimum date of the project start, which will be the first day of the project start, baseline start, and the maximum date of the baseline date. So this will be our project duration. So let's go here now. What I'm going to write, that the minimum of, okay, what baseline, you write BL, so it should give you the available options. So if I go here, check, these are the available options: baseline finish, baseline start. So the minimum of the baseline start date, okay, and then put this comma, what is the maximum date? The maximum of the baseline finish date. So BL, if you write, it will give you this. So this will give me the project duration, original duration. So project baseline, maximum date. The last argument is what type of difference you want. So in our case, we don't want week, we don't want year, we only want the day. That means 365 days in a year, so it will give me the duration in the form of days. So now if I go and check project duration, it is here. So in order to just check that, so what you can do, it's a visual card. If I just put it here, so the total duration is coming 839 days. So what you can do, simply just check your baseline duration in the contract duration. If maybe you need to add +1 or -1, you can add, because sometime our calculation says that if you have 2 dates available and you want to calculate a duration, you need to do +1 in the end. If you have one date, which can be project start date, and you have the duration, and you want to calculate another date, which is a project finish date, you need to subtract 1. So sometimes P6 calculation is different, Excel calculation is different, and Power BI is different. So you need to check what is the total duration of project. So maybe you need to add +1 or -1 in order to make the equation satisfying. Okay, so these are the dates from the baseline. So there is one more option to check the delay, or you check not delay, you need to check the forecasted finish date, because not necessarily this baseline date means your project is going to finish here. You might need to know that, okay, what are the current situation in my program, in my project, that what is the forecasted date. This is, which one is this? This is the forecasted date. It can be beyond the project finish date, for baseline date. For example, this is the baseline finish date and it is going after that. So baseline project duration is coming from here, from baseline start, baseline finish. But you might want to also know that what is the current forecast duration, showing me that how much my project is going to be away from the baseline date. So you can also create the same formula and you can go here and make, let's say, a new measure. It's your choice if you want to have that, but these are the options. I'm just showing that you can avail. So date difference, minimum baseline, because baseline start date is the same date. Maximum of, from here you can just remove the baseline instead and bring here the activities fact table. You need to be in activities fact table and just go for the finish date. This is the forecast finish date and just put that here. Okay, and press comma. The formula is set. So it might give you more duration because the forecast date is changed. Okay, we need to just change the name. Both names cannot be same. Project duration, and you can name it forecast. Okay, so it may be little bit different. Let's say let's see how much value is coming here. See, it is different. It is showing me now. I can say that this is apparently the total float. Difference between them, you can calculate the difference between them as a delay as well. Okay, so what else do we need? Now we want to calculate the project elapsed duration. So I will not be using this as a measure because I don't want to use this. I want to use compare through the baseline, but if you want, you can calculate from for yourself from the forecasted date. So forecasted date can be changed in every update, so they are variable. So I will be working in this whole training based on the baseline dates. So now I'm going to calculate the project elapsed duration based on the baseline dates. If your case is different, for example, your baseline dates are already gone and you are following the forecasted date. For example, your baseline date was 1st January to be finished and you are here in the, let's say, end of the January, and your EOT is not approved and all these things going on. So definitely if your baseline date is already in the past, so you need to use the current dates, or maybe you need to revise the baseline. So it's up to you. So next, what I'm going to do, I'm going to make a new measure. I'm going to name it time elapse. So what is time elapse? So time elapse is actually the start of the project until the data date, whatever you data have, whatever is your data date. So this is your time elapse. So in our case, we do not know what is the data date. Maybe you know that from the P6 that this is your data date, but we don't want it to be a static time elapse. What we want to make a very robust system. We want to make a very comprehensive, a very dynamic and system. Yani you can change the data date here and there, left or right, to and fro, and your data should be changing. So for that, what you need to do, I need to explain here one thing more first, that this is my filter here, and if I put this date, for example, this is my date here, so this date can be changed. Based on that, the data can be changed as well. Any data, for example, let's bring one data here and we will see what I'm going to bring. I'm going to bring the plant value which we just calculated. It's already there. or the percent you want. Okay, so if I change the date, you see that this value will be changed because the data date is changing. What data date is telling me, let's say I want to bring that data date here. How I can show that? What is my date? This is my date, and there are few options. So I want the latest date. Earliest date means the first date. First date is this one, but this date I'm not going to change this filter. I'm going to change the filter from start of the project until the data date. Now this becomes my data date. So this one is the latest, this one is the earliest. So in this case, what we are going to do, we are going to use, for example, here in the date, it is asking me the earliest date or the latest. I'm saying that I want always the latest date because latest is my data date. So now you see, so I can just change the context here. How? For example, day dash month dash year. This is easy. So now it will change the values accordingly. So now what I want to show you here, this becomes your data date. In P6 you cannot change your data date backward and forward and see the result because you have already applied the actuals. But in our case, if we want to see what happened in past, let's say I'm here back, so date is changing here and also the values are changing. So we also want that if my value is changing for planned value, earned value, SPI, CPI, if everything is changing with the time, why not the time elapsed should be changing with that as well? So that's why what I'm going to do, I'm going to use this value for the time elapsed, not the static data date, because we want a variable data date inside our model. So for that, let's now dive into again the project time elapsed. New measure. I will call it time elapsed is equal to, so what is the time elapsed? The first day of the project until the data date, which is variable. So first day you can see, simply call it minimum of what? Baseline start date, because we are sure that this is the start of the project. Baseline start date. Okay, fine. Second for that, before that we need to write here the date diff formula because we want to create the difference. Date diff of this. Now the second argument says the maximum date. What is the maximum date? The maximum date should come now from this part. This part is date. So what I am going to say that the maximum of, okay, DATE, I will write date. So now the date table is here, which is this one, and inside that these are the columns. So I want this column, the maximum of this column, and the interval should be this one day. So now my project elapsed is a variable. It can change with the time. If I'm standing here, it tells me the project elapsed so far at this point. So let's see if it works. Okay, what we are going to do, we are going to make a new card and time elapsed 328 days. If I move that forward, this will be increasing. You see 447 days. So now we have a variable time elapsed. It will help us in analysis later once we will be making the dashboards, that you will assess what was the time there, how much time was remaining, what was the project percent completion of the time, how much elapsed percent of the project, and all the dates are changing. So it's very, very powerful during the analysis time. So now the next thing is that, okay, we want to have a percentage as well. So let's say quickly create a percentage. New measure. And I will call it time elapsed percent is equal to divide formula. And what I want this is a measure. So now we need to understand, if you are using a measure, because we know that these all are the measures because they have a black calculator sign. It can be different color or something, but it has a calculator sign. So measures are used in a measure. So that means you don't need any aggregation. You can simply use the measure. It is a scalar value already. We know that. Why we were using the aggregation like sum, minimum, maximum? Because we wanted to convert the iterative values into the scalar values. So now this is already a scalar, so we don't need any minimum, maximum thing. So simply I will call it, okay, time. So it will give me the option as well. Time elapsed in numerator divided by what we want. We want to divide it with the project duration, which is this one. So project. So it is giving me both the options, but I want this baseline one. So this will give me the percentage of time elapsed, that how much percent elapsed, 50%, 30% and all this. I can convert that easily into the percentage from here, 2%. So let's say see the percentage. See 26%. If I move forward, the data will be 61% time elapsed. So now time remaining, we know that it's simply the difference between them. So I can quickly go in here, quick measure, and subtract the value. I need a subtraction of what? I don't need time elapsed here, I need here the project duration. So what is the project duration? Project duration is this minus the time elapsed. So this will be time remaining. So I can call this time remain, and for its percentage we know that we simply need to divide. So let's say we want to time remain and divide this by, you can use many ways. Sometime I use a measure as a formula, sometime I use quick measure, whatever you need. So time remain divided by what? The project duration. So this is the project duration. So it will give me a variable, a dynamic time remain range. So let's see this as well. I will just copy that and time remain percent. Just bring it here. So okay, I need to convert that into percentage first, percent and 2 digits. See, it will be exactly matching them. Okay, so this is done. So now there are few more functions which we will get introduced with, and then we will go with the most complex and most powerful feature of the DAX, which is calculate function. So what else we can do? We can use some count distinct formula as well. So just to give you the little knowledge you can explore. Now I have explained you the context and the syntax of this DAX, so you can just do brainstorming as per your need. You can modify many things, whatever you need, the formulas. But what I have done so far in my all research and in my all this development of this course, whatever we will be using, it's quite advanced and it's enough for us so far. So but it's a subjective thing. Whatever you need, you can explore more. So what is the purpose of distinct count? We have seen previously that we were counting the activities. So what happens with the count activities? Let's say I will go here and I want to see that the number of activities are how many? 5764. Let's say I want to check that whether they are fine or not. So there is one more feature. I don't want to put this, I can just simply put this and it will give me options of what you need, the first one, the last one, or what. I will say okay, just bring the count. So if it brings the count, see both the values are same. Here we are using the built-in function count, but here we have used as a measure, so it also gives the same value. So what is count distinct count? So let's say if I bring the activity IDs from another column or another table, I want to know the activities in this part, let's say in activities distribution. So activity ID, I will bring that here, and I will ask that count. So it will give me like in thousands, 22.5 million means so many. And we know that, I know the reason is that it has activity ID repeated for actual cost and actual labor unit, plan value cost, plan value labor unit, earned value cost, earned value labor unit, and each activity is finishing in multiple weeks. Some activities are finishing in 4 weeks, some are 10 weeks. So for them, if activity is finishing in 10 weeks, so it will be repeated 10 times because we did unpivot. So that all 10 weeks, week 1, 2, 3, 4 now are vertically present here. So each activity is repeated 10 times as well. So that's why the combination is going 2.5 million times. But actually we know that the unique IDs are here. So let's say if I want to see, so if I count here distinct count, so it is giving me the unique values. Now it also shows me that the fact table cannot have a duplicated value. We know that it's a primary key. So these are the unique number of IDs which are coming here. But if we want to see that, okay, in this table how we can find the distinct value, means unique value. Right now I am using this one. So if I use this, it is showing me that many values. So how we can use the distinct value? So there is a formula for that. If you want to use, simply I will go here, new measure, because these formulas can help you. Distinct count. Okay, for that simply distinct count formula is here. So it will ask you column name. So you can simply give the column name. What is the column name? We want activities distributed. Okay, these are the activities. Inside that we know that it was showing us 2.5 million count. Now it will show me the distinct count. So these formulas can help you to make some your analysis later if you want. For example, you want to find the how many distinct engineering works and number of activities, different type of, so you can use these combination to make your own KPIs or milestone if you need. So that's why I feel that these things should be explained here, so that if user want later to see, they can. Now you see distinct count, the formula is giving me the same value. So this is one of the feature. Same you can use the maximum, minimum and all these things wherever they are applicable. So now I will move into the little bit of more complex thing, which is the calculate function. So for that I need to explain you what is calculate and how it is used. We will be using calculate quite oftenly here. So what calculate, before calculate we need to see one more feature. So far what we have done, every measure DAX which we used, we have used it for measures. All are the measures. We didn't use yet for the calculated columns. So let's say how we can use calculated column as well. So for calculated column, all you need to do, simply first of all go into the column. Let's say I will go for actual cost. I want to calculate here the percentage of this. So how I will do, I will say okay, new column, and I will call it actual cost distribution percent. Actual cost distribution percent. So how I know that I am using the columns tools, and I know that here is the symbol showing me that it is going to be a column. Okay, this is also iterative value. All these are iterative values and columns. This is also an iterative value, but the symbol is showing user developed this value as a column. These were coming from the Power Query itself. So what I am going to do, I am going to calculate the percent. So how I will calculate the percent? I need to simply divide. The same formula will be used. Divide, what is the numerator? The sum of, because this is an iterative value, so we need to aggregate that sum of ACD. I wrote this, so it gave me automatically these values. So what I need to use from there, where we have DIS, the sum of this value, okay, divided by what? The sum of budgeted total cost. So I will write BUD, it will give me budgeted total cost. Why? Because is actual cost we are using, not the actual labor. So this will give me the percentage, but the difference is that this percentage is coming as a column, as a iterative value, not the measure. So I usually prefer to use measure. It both can be used. There is no much difference so far I have found. So there is nothing to basically go into which one to use. So the point is that this is the way you can use the iterative values. So now if I go into this column, the advantage is that this value now can be seen here in this part, in the data tab. So let's say I was in this area. Now you can see the activities distribution, activity cost distribution percent here. I can convert that into percent, and this. So now you can see this is converted into percent and two decimal places. So the difference between this measure, this calculated column, and the percentage of, let's say, any other value which we have calculated, so for earned value, the difference is that this earned value percent cannot be seen other than the visual, but this calculated column percentage can be seen in the column here in the table, and then also in the visual. So it's your choice, whatever you make. So if you want to make through this way, you can develop through the calculated column way as well. So that is not going to make any difference. Okay, so that was a calculated column. Now we will move towards the calculate function. So let's see what we want to do through calculate function. Okay, what I'm going to do now, I'm going to say that for example, the sum of, we know what is the sum of earned value here, we did not have, not yet. Okay, sum of the planned value here. So now I want to calculate the sum of planned value from the other field, but if I bring here, let's say this part, and if activities distribution, we know that the sum value is already there, any planned value. So how we know that? Let's say I first of all want to show you that what are the values hidden inside this part. The values hidden inside this, that sum, which is distribution sum. Distribution means horizontally distributed against the time, and sum is showing that it's a whole number, and of what? Of these values. What are these values? Actual cost, actual labor. So that means if I want to sum this, it will bring the sum of all the values. So let's say how it works. I will bring this and it will show me sum of huge sum. But if I see the plan value at this point, the plan value sum will be 300 something, 386, and it is showing me 1 billion. So that means plan value, which is this one, and also other values are coming here. But if I want to extract only the plan value from here, so I need to give command to DAX that okay, bring this data for me. So for that we can use the calculate function. So at this point we will see that how powerful this calculate is. So let's say I'm here in this part and I want only planned values to be come outside. So just come with the new measure. Sum plan, okay, because these values are just for the introduction to the DAX and some, you can say, writing DAX codes. But in the next part we will be developing the standard KPI. So at that point in this session, in that session, we will not be using these values. These are just to inform you that how the syntax is used, how the context is used for the filter. But these values we will be using plan value percent and the time elapsed percent, but this distinct count, they are not used in our reports. We will not be using. In case you want, you can follow that simply. So sum plan. So what is our target? We are going to say DAX that calculate is very powerful function. What it does, it manipulates the data for us as per our need. Whatever the operation we want, first of all we need to see what are the arguments. First argument is expression. Expression means you are asking DAX to do something for me. It can be sum of something, it can be count of something, it can be minimum value, maximum value, or whatever the operation you want DAX to calculate for you. The second argument is saying that what you need, what is the filter you need there, means what is there anything you want me to do. So I will translate that these two arguments for you to make it easy for you. Let's say what I want, we want here that the sum of, we are saying DAX, please bring the sum for us of what? Of distribution unit. It says okay, distribution unit is DIS is present in so many areas. What you want me to do? Definitely we want this to go into this area and find the distribution unit, DIS unit, which is this column. So it says okay. So we know that whenever we use aggregation, we need to close that. It is closed. We can close it here as well, but it will be a simple sum. But now it is asking me that once I press the comma, the filter context, which is the second argument, is activated now. So what happens, the calculate now is expecting that user wants me to calculate the sum of this column, and the user also wants me to do some calculation, do something, means do not just bring the formula, just do something else to me. It's just like when you call to book your food or something, you say that kindly book the food for me. What operator says, do you want me to do something else for you or just that? So similarly the DAX is saying, do you want me to bring only the sum or something else I should do? So now this is the point where we can use so many combinations to manipulate the data. Not manipulate, I should rather use the word, we can alter the data as per our needs. So this second argument of calculate is very important to understand. There can be 2-3 type of filters we can use. So right now I will be using the Boolean filter, which is a true or false, which is having only 2 conditions to follow. So what I will say now, bring the sum from this column where the spreadsheet field. Now the spreadsheet field is available in so many places, but we know that we are in activities distributed. So just go into activities distributed, where the spreadsheet field of this is equal to what? in Boolean we need to give the hard reference. I want to tell that where the spreadsheet field is equal to planned value cost. So okay, this is not a case sensitive situation for DAX, so you don't need to worry, but Power Query is a very strong case sensitive. If you write capital P or small p, there will be a different situation scenario. Here you are not worried with that. So but I am using the same thing, planned value cost. So this is the reference I gave this. So now you will see whatever the measure comes here, the name is sum.plan, it should give the separate value. You see the sum of planned value is this. While I was using this, the value was 1 billion. Similarly, if I want to change that, I can say that instead of planned value, let's say I want to find the earned value cost. So now you will see the value will be changed. See, the value is changed to 384 million. So if you want to confirm that, we can go into earned value cost and we can bring the earned value cost here and check 384. Okay, because we are in earned value tab, so the total cost of earned value is this, and after our measure which is this, and we said that bring the earned value cost. So this is how you can use that a Boolean filter, where you will give the hard reference that from this part bring the XYZ operation, and when the XYZ field is equal to ABC whatever. So this is the case to extract out the data from something. So far we have seen that how we can use calculate and find out the results as per our criteria. So in case we want to add more criteria, let's say we want to calculate the earned value cost, and also we want to calculate along with that planned value cost. So how we can do that? For that we need to use a function, it's called for example, let's say if I want to use 2 times OR function, so criteria is that I need to use OR. For example, for that, before I need to bring here OR, so it will bring the function OR, and now the logical test says this first test, and the second logical test will be, let's say I want to copy the same thing, and I'm saying that okay, from that bring the planned value cost. So I will replace this with planned value cost. So what will happen, that previously I was getting only the earned value cost, now I am extracting the planned and the earned, both the cost from that 6 values. So let's see what will happen. You saw the value is changed to 771. Why? Because it is now bringing the earned value and the planned value cost. So if you want to verify, see here it is 1 billion. So if I click on the planned value cost, it will be 300 and something 86, and if I click with along with earned value cost, so they both are same. So the same function which we are doing here physically, like external filters, these are the explicit filters and the external filters, and anything which is used inside the calculate, inside the query, it's called the implicit filter. So we have used implicit filters, internal filters, and the result is same. So if you are using at least two conditions, 2 criteria, so you can use OR. But if your criteria is more than 2, so let's say we want to calculate also the planned value labor unit, we want to bring that as well in our criteria. So in that criteria you don't need to use this one, you can ignore that. Instead you will use this pipe function, vertical pipes. So this vertical pipe is actually the OR argument of the formula, means it is saying that bring this condition, yani bring some formula, bring the formula sum of this distribution unit, and fulfill this condition, that wherever the spreadsheet field is equal to earned value cost, or this spreadsheet field is equal to the planned value cost, 2 conditions, third condition, or again the same situation we will use, we will just copy that from here to make it quick and paste it here. The third situation is saying that we want to include the planned value labor unit, so PLA, planned value labor and units. Okay, so in that case what should happen, our value should be increased something, because right now it is, there are 2 values, there should be third value, so it will be increased. 771. So let's see what happens. 779, because some man hours are added. So if in order to verify that, what we will do, simply select another one and see here the result will be same. So this is how you can use different combinations inside the filter context of the calculate, because calculate can do a lot of things for us. We can just maneuver a little bit of filtration, what type of filter we want, and all the data can be transformed as per our requirement. So now I will go into a little bit of further into the calculate function, that how we can use the calculate function for the cumulative formula, because we also need cumulative. We are comparing plan value, earned value, and we need the cumulative values. So there is a quick way to do that. So first let me show you that how we can make the quick way of cumulative. Let's say I want to make a cumulative of plan value. So simply click on plan value, go in quick measure. You can click anywhere and go into the quick measure, but if you click on that particular item or column, so it will already be there included. So what I need in Power BI DAX, they refer running total as the cumulative. So running total we need to use. See, it is already there, base value. Running total, we know that is a cumulative value, and cumulative value is calculated against the time. Time means in every particular time you are adding the previous value in order to get the cumulative. So if I'm standing in the February, I will add up the January. If I'm standing in the March, so I will add January and March both. So we know that time period, where it is, time period is here. And now we need to recall where from this came. Yani what is the current situation of this data set, and what was the source situation of this data set. The source of this data set is definitely, we know that it's a Primavera P6, but how the data is transformed from P6 into our data structuring, what happened there, how data was changed, for example, from horizontal to vertical. Then what is the current situation here? So we need to discuss that. So far we know that this is related to time, and how, because this date ID is connected. We know that we have learned in the previous session during the data modeling, we have connected this date ID, which is a primary key, with every column's date ID, with all distribution columns tables date ID. What are these distribution tables? Earned value cost, actual labor, earned value labor. Every particular table which has DIS written, it's a distributed. DIS means they must have this date ID. This date ID here is a foreign key. Why foreign key? Because this date ID is repeating multiple times for multiple activities, maybe for raft, for steel fixing, for formwork, for concrete. All the different activity IDs are happening in the same date ID. So but the IDs are different, activity IDs are different, so this activity date will repeat for multiple IDs. So that's why the date repeating again and again, so it becomes a foreign key. But the same date, when it is present in date ID, where we did the remove duplicates, and we made in the data structuring in Power Query the unique value, so it becomes a fact table. So we know that it's a fact table. So fact table here repeating here becomes a dimension table, and we know that DIS is a dimension table. And we also know that anything which is inside dimension table it can be either an attribute, or maximum it can be a foreign key. So this is a foreign key. So all the IDs which are these are connected to the foreign keys of each table. Every table has its foreign key. So that's why we know that if I'm taking the plan value, so I must take this value, because this is connected with the primary key. So this is relating to the time, and this primary key we are using here in the slicer. So if I move the primary key here and there, this primary key will go and tell this column, this table, that my primary key is changed there, so you need to change yourself. And once it is changed, it will force this value to change. So that's why we are using this formula, and we will go into the detail of how the data flows, which is called data filter context, that how filtration is happening, how data is moving from one table to another table. But this will be coming in the later parts. So this is so far that we need to use date ID. So what we did the quick running total, sum of planned value against this time period, so it will give us the value of cumulative value. So now we need to see how cumulative values are appearing. So I will just make another sheet, and I will take the time period. Let's say I want to show you something. I will take time period here with me. I don't want to sync, and let's bring something which is okay. This is because this will give us the cumulative value. How I want to check the value, so I will bring them into the line. Okay, and let's say what is the time is this, and I will bring that into the axis. So once it is in axis, it will make an S curve for me. You see, now the S curve is coming properly. So that was a quick way to generate the S curve. So remember one thing, whenever we are using S curve or whenever we are using time period in the axis, we will always go into the fact table. We will never use these foreign keys. We will always use the primary key. We can use index as well. We can use end of the month and start of the month. Why we have written end of the month, we will come to that little later, because the month can be same. The January 1st will always be January 1st. The January 31st will always be the end of the month. But January 4th can be start of the week for you. Maybe your project started on the 4th January. The start of the week will not be the 1st January. It can be 4, 5, 6, any January. So that's why this thing is a subjective. So start of the week you need to make as per your project start date and as per the weeks you are working with. Some people have Sunday as off day. Some people in the Gulf area, the Sunday is a working day. So this you need to adjust, and it can be adjusted easily. But the month is always same. If you are saying the end of the month, for January it is 31st in any part of the world. So that's why we have developed this. So what I'm going to do, I'm just saying that we need to always use dates in the axis of any visual from this part, which is a fact table. Okay. So now we know that quickly how to make it, but we need to understand how it is working. We need to understand that what DAX is using in order to bring this data for us. If you see the formula for DAX, it's a very complex formula. It is you know what is written here, so many things written here. Maybe you are not definitely you are not able to understand that right now. If you already know DAX, so still you come to know that it's a complex thing, is on or after the max date. But we are going to make it simplified formula, yet it will be little complex, but we will understand that how this formula is behaving. So let's start with the calculate formula in order to calculate the S curve. So we will make the S curve for earned value cost distribution. And how we will make that? I will go into this part and I will say that new measure, okay, and the formula will be earned value cost distribution cumulative. You need to be very choosy in some few things, that whatever the context you are writing here, it should be similar everywhere, so that you will understand. If you are writing cumulative later, so it should be later. If you are writing cumulative in the start, it should be in the start. So let's say we are writing cumulative in the later part. So earned value cost distribution cumulative, then equal to, now I'm saying DAX that calculate, okay, I will calculate for you. What? Calculate for me the earned value cost distribution sum. So sum of, okay, sum of earned value cost, okay, in this table, okay, I want to calculate this, fine. So far it is fine. Now it is asking me what you want me to do else. So just make it little workable. Yeah. So what you want me to do else? I want you to go into the filter part. Filter will allow you to go into any particular table you want. I know that which table I want to go. I'm telling DAX that calculate the sum for me from this table and this column. Now I want to shift to another table, so I wrote the filter, okay, the table, it is asking me the table context and filter context. Then I will say that within filter I want to use all or all selected. They both are same. The only difference is that all select, this all return all the rows in a table or all the values in a column, ignoring any filter that might have been applied. So we need to understand what does that mean. Before that, I will just tell you what all selected says. It says return all the rows in a table, means whatever the rows are present in the table, whatever table you have select, all the rows in a table it returns, or all the values in the column, means all the values in the column it will return, ignoring any filter that might have been applied inside the query. That means if you have applied any filter inside here, it will ignore that, but keeping the filter that comes from outside. Okay, so this is very important for that keeping the filter that comes from outside. So what does that mean? See, keeping filter means if I change the date from last day of the month to the 15th of the month, so that means it will respect that filter, it will keep the filter. Okay, so if my date is selected there, let's say if I go outside of this context, I want to show you that what is the meaning of keeping external filter. We know that these are external filters because it is there. I'm using here as a visual, so it is always an external filter. Anything which is used inside the formula is a internal filter. So it says keeping internal filters, ignoring internal filters, but keeping the external filter. So keeping means right now it kept the filter like until this point, but once the user changes filter, now it is keeping the filter until this point. So what will happen? All selected will do, it will ignore any filter inside, but it will respect whatever user has selected. So if the user is changing the data to this date, so now DAX is bound to calculate the sum of what? Planned value, earned value, actual cost, whatever user has said, calculate the sum for that and keep this filter which is coming from outside, which is a date filter that start from here, go until this part and calculate it. So it is calculating until this point. This is the part. So DAX has used its own formula, but we are using our own formula. So what I am going to tell that all selected, because we are using all selected, we want to use the external filter, we want it to respect. All is not respecting. It says it will return whatever user has asked, ignoring any filter that might have been applied. It will ignore all the filters, but this is not the case. We want external filters to be working. Why? Because maybe this is the S-curve of whole project. I want the S-curve of, let's say, concrete works. So I want to externally in the visual, I want to choose extra concrete or finishes or MEP. So all should not be respecting that. I want it to be respected outside the query, but keeping the filters that come from outside. So that's why we will use this all selected. What all selected is saying? I'm saying all selected of what? Tables. This which table? Date ID. Now I am moving into the date ID table. Okay, this is the table and this is the column. It selected the table and the column. I will close this. So the second part is that I have selected the table. See, I choose the filter to go into my condition, which is saying that user want external filter to be respected where? Inside this table. So now I am inside this table which I want actually to use. The second argument is saying filter expression. What is your filter expression? Okay, the calculate is said I am going to calculate the sum for you, and now I am going into another table where the user want the external filter to be respected, and the table name and the column name is this, but there should be a criteria. What criteria user want me to do the outside, means outside. What is the criteria? The criteria says that the date, which is the same column we have used, the date ID column should be the less than equal to of the maximum date. What is the maximum date? The maximum date is the date of this part. So now I need to actually translate for you what it says. First I will show you the result of this formula. We calculated here, so I will just bring it here. Okay, so we need to use another axis. Definitely I will just go and use another axis. Let's say axis is open and the secondary axis is on, and I will put that into the second axis. Okay, I need to use for that this line. This is having two axes. Yeah. Okay, now you see. Although they shouldn't become, because I think I used there a percentage or something. No, I will see that why they should be same. Okay, so what is happening now? Let's say I just remove this and I'm working only for the S-curve of this. So currently it is working on for month. If I just drill down once more, it will be the weeks. It will go into the weeks because these are the weeks. And these are actually whatever the least part you have exported into from the P6. If the scale is week, it will be the week. If the scale is month, it will be the month. So now the point is that this is our formula, and now it is showing us the S-curve which we made. If you click here, this is the measure, and here it is the formula. So now what happened? I will just bring that little down to make it easy. Yep. So now you see that it is doing what? Calculating the sum of earned value cost distribution which is coming from Primavera, okay, and I am asking it to, after you calculate, go into another table. For that I use the filter, okay, filter allowing me to go into any table I want. I said okay, I want to go in another table and I want that the external filter should be respected. For that I wrote this, and what is the table I want to go? I want to go into that table, okay. The criteria, what it is saying, it is saying the criteria is that date ID is less than and equal to the maximum date ID. What is the maximum date ID? The maximum of date ID is this is the maximum. If I move this is the maximum. If I change it to that, this is the maximum. So it is saying that the date ID should be less than or equal to the maximum of the date ID. So maximum date ID will be the last day, and wherever the date ID is less than, just bring the data until that point. So that's why if I change this part, so what is happening, it is bringing the data only until the maximum date and less than that. So less than that is everything before that, from here until this point is less than. So maximum, less than and equal to the maximum date. So that's why once you move this, your S curve becomes dynamic. So that was the essence behind it. But there is one thing more we want to discuss. For example, now if I bring that part here, so I need to check one thing why it is not coming. Let's see the reason. Date ID, maximum date ID, we have used that date ID is on or after. Okay, what I found so far is that we have used here the plant value labor unit, and here we are using earned value cost unit. So that's why they are not matching the case in one scale, because the scale of plant value is very small. It's in millions, like 4 million, 5 million, while the earned value is in 300 million. So that's why. So if I do what I do, if I just go into the plant value cost and I bring the cumulative of that, then it will make sense. So right now this comparison is not apple to apple, because we know that it's L labor, C cost. So I need to remove that. So let's say I want the cumulative of plant value cost. Quick cumulative, let's say I want a quick cumulative, we want to see that, and the running total, which is this, and the time we know that is this, date month ID, and use that. So I will bring that, so they will be parallel to each other, not parallel, but they will be on the same axis. They can be used in same sheet. See, now they are used. So the dark purple one, dark blue one is the plant value, and light one is the earned value. So the point which I want to show you here is that earned value is until this point. After that it's showing a straight line. Okay, let's say I want to bring earned value in second axis, and here you might see that earned value is used at a certain point, which is now the earned value is dark one. After that earned value is only straight. So let's remove this, and you see here the earned value is straight. This is not good. We don't want that. So for that we need to do something. Here we need to understand the filter context. For that there is one thing we normally use in DAX to normalize the formula, to make the formula work easy for us. How we do that? Let's say in earned value, now I am going to do something which is called the variable. So I want to store this formula, store one formula as a variable. In order to write variable, what you do, simply write var, okay, and then you need to give a variable name. Just like in Excel we give name to some table, and then we can recall that table. So what name we can give? Whatever name. For example, I can what I do, wherever I am in earned value, so I will give name related to earned value, but the name should always be last date, and what is this? Earned value cost. So I can write, if it was last date of plant value, so I would have written plant value cost, PVC. So it's last date EVC, which is equal to. Now I am storing this formula in the memory of this last as a variable. Later I will use this variable. And what is the formula? I want that calculate. Okay, now we see how powerful calculate is. The expression says calculate for me the last date. Last date is a function which returns the last non-blank date, means it will return the data until the non-blank date. So last date of what? Last date of the part where my earned value is there. For example, I want the last date of this portion. So last date of EVC. In EVC, where is the date? This is the date. Okay, last date. What is the filter context? Filter says that where the EVC itself, the earned value cost distribution itself is greater than 0. This is the concept. Why? Because if you see right now the S curve, it is increasing, so that means earned value is increasing in each month and adding the previous month, previous month. But when the earned value is here and time period is moving, but the earned value is not moving, it is constant. So that means from this point until the last point, earned value is not increasing, it's 0. Earned value is 0, but adding the previous one, so the cumulative value stays same. Although cumulative value should increase if the current month value is increased, but current month value is not increased. So that's why what we want that if the current month value is not greater than 0 or not any value which is 0 or less than 0, in fact there shouldn't be any less than 0. If the current month value, what value? Earned value cost distribution, plant value cost distribution, earned value labor, actual labor, any value which is related to time period, if the value of that particular date or that particular month is not greater than 0, then shouldn't be giving the answer to me. So that's what I wrote here. I said calculate for me the last date of this table, yani earned value cost distribution date, bring the last date of this table where the situation is satisfying. Situation says earned value should be the greater than 0. Wherever you find the earned value greater than 0, bring the last date. If it is 0, then don't bring me the date. So this is what we have done here. We stored this value. So now what we want to do, we want to return it. Whenever you write any variable, you give the name to variable, then you make it equal and give condition, whatever is your condition. Then next step, if you want to use that variable, you need to write return. So now I'm able to use that. It is now in the memory of DAX that this variable user has created and user can use anytime. So once you have written, after that return, what I will do, I will go and make a little condition that if first argument logical test, and it says if the logical test is true or false, so do whatever you want. First argument, second argument is if the logic is true, do this. If the logic is false, do this. So what is my logic? My logic says that the maximum of week date ID means date ID. The maximum of, I am going into the date ID table and date ID column, that the maximum of this part. Why close the bracket? Because we are using the max value, which is a scalar value, so that whatever the maximum value of this table, and maximum value always remember is this. If this is here, so this becomes the maximum value. So the maximum value, if this is less than what? Less than my this value which I have just stored, less than the last date earned value. If the situation is satisfied, what you need to do? Blank. Make it blank. If the situation is, if it is not blank, means if the situation is otherwise, then use the same formula for me. So see what will happen now. Let me see if it is okay. Okay, let me check that. I think this is the situation. Opposite, I need to write maximum. Yeah, see, the situation is changed. So what changed now is, if I now bring the plant value here, you need to see that the earned value will be shown until this point. Okay, because this is the point where earned value has something greater than 0 in each month. In this month some value is present, in this month, because it is adding up. After this point there is no earned value, and this can be the case with you, because if your project is of 2 years and you are standing at the 3rd month, so definitely remaining 21 months you will not have any earned value. You did not do any work so far. You will go in the future to do the work. So if my project is 24 months, I am standing at this point, I don't want this horizontal long line passing through my visuals to make a very irritating visual. So I want them to be removed. So this is the point where my data date is present inside P6, because after that there is no actual progress available. After that there is no earned value. So I want it to be stopped here. So this is the case. Similarly with the plant value, maybe plant value is stopping at this point, it shouldn't go until the end because it is stopped here. So what we did, I will just now recall all the things which I did so far in this formula. I calculated the cumulative formula, which we know that calculate sum, go into the filter, in another table use the filter, all selected. I want this condition that the current date which user has selected should be less than or equal to the maximum date. So see, now it is changing, but I don't want this date to be shown, this line to be shown. So for that I said to DAX that store a value for me as a variable. The value says the name, you can give any name, XYZ. The name says last date earned value cost, and the condition is calculate for me last date of this table where the earned value is present, means the user has actual progress available. So actual progress is there, so calculate that. So now it is saying that if the maximum date ID, means if this selected date, this maximum date is now, for example, until the end of the project, this is my maximum date. If the maximum date is greater than last non-blank date is this point, because earned value is stopping at this point. If this date is greater than this date, then what you need to do, bring the blank for me. See, it is bringing the blank. So all those part where the maximum selected date, which is this one, is greater, bring the blank. So it brought the blank from here until this point. So again it checked that okay, this is the point now where the maximum date is not greater than last date. So now what we'll do, if the situation is not that, bring the S curve for me, which is the below formula. So that is what actually we did here. So we have understood quite basic to advanced of DAX, because these are the formula we will be using, and there are many formulas, but we are not concerned with them. So if you want to explore further for your personal KPIs and personal different kind of analysis, you can use, but we will be using only these formulas, and there are one or two more which we will use once we are developing the dashboard, because if I use them right now it might not make that sense, because it requires a visual explanation. Once we are using that visual, then it will be making much better sense. So I hope this DAX is quite understandable to you. You need to practice that, and from the next part we will be using all these formulas, and we will be making the remaining KPIs, which are SPI, CPI, EAC, for all the parts. So that was for this session. Inshallah, see you in the next part. Thank you.